Hi everyone, today we're discussing chapter 8 and I will be covering few factors, few important things which you are supposed to understand for you to be able to answer your exam, which is upcoming. So chapter 8 we're trying to cover few things, i.e. the relationship between inflation, unemployment, and expected inflation. So previously, we did discuss the factors which affect inflation and their implication. So there are a few things you are expected to cover, but mainly three things, i.e. show how the model of labor market, as we saw previously, imply a relationship between inflation, expected inflation, and employment. Second, we expect you to be able to use the relation to that relationship to interpret the mutation of Philip curves over time. Lastly, we expect you to be able to show the relationship between Philip curves and the natural rate of unemployment. So let us start. I'm going to start by giving you a simple background on inflation, expected inflation, and unemployment. So in 1958, Phillips plotted the rate of inflation against the rate of unemployment, and he found evidence of a negative relationship between inflation and unemployment. In 1960s, Paul Samuelson, Robert Solow replicated Phillips exercise, but this time using US CPI from 1960s, and they also found a negative relationship between unemployment and inflation. Soon, this finding became the center in macroeconomic thinking and the policy making. Their finding implied that countries could choose between difference, inflation, and unemployment rate, i.e. there was a negative trade-off between inflation and unemployment. So countries can either have high unemployment at the expense of, can have lower unemployment at the expense of higher inflation, or you could have a higher price stability at the expense of higher unemployment. So going forward from then, the discussion becomes the search for the correct target, i.e. the anchor on the Philip curve. So in chapter 7, you recall that we discussed wage setting and price setting. So wage setting, we said wage was a function of expected price, catch-all variables, and unemployment. So you remember that the catch-all variable actually measures the structure and institution factor that contribute to wage determination, the level of unemployment benefit, the labor market protection, minimum wages, legislation, etc. The function F then is assumed to be decreasing in unemployment, as higher unemployment reduces workers' ability to bargain for higher wages. Wage setters take into account the bargaining of workers in wage negotiation. From the price setting relation, we further derive a relationship between price and wages and using the markup. So surely, if you make an assumption that you are operating under perfect competition, you get the relationship depicted in equation 2. Those two equations, so equation 2 tell us that actually, if we assume that the slope of the price setting curve is more generally likely to be positive in unemployment real wage space. But if you assume marginal product of labor is constant, then you actually get the horizontal price setting relation. Now, for simplicity purposes, we set the relationship between unemployment and the function of FUZ. We make it to be linear, where alpha is a response coefficient of the unemployment wage to an increase in unemployment. We employ wage setting and price setting models to compute analytically the natural rate of unemployment. To this end, note that the natural rate of unemployment rate is a medium-term concept, which holds when current price is equal to expected prices. That is calculated under the assumption that nominal wages in equation 1 can be replaced with nominal wages in equation 2 to obtain the following equation. The equation implies that an increase in wages in the expected price, i.e. an increase in expected price in equation 1 will actually lead to increase in wages, and the increase in wages in equation 2 will lead to an increase in price in equation 2. So remember that. So this is a very important thing, and observe and make sure that you get and you understand. So, i.e., an increase in unemployment rate will lead to a decrease in nominal wages. Your bargaining power is decreasing, so you can't actually ask for a higher wage, which in turn will lead to a decrease in price level. So if nominal wages are decreasing, i.e. in equation 1, prices should be decreasing. For convenient, we write, as I said, we can rewrite such function as 1 minus alpha u plus z. We show that if you increase your unemployment, your wages will fall. And if you increase your catch-all variables, your wage, i.e. bargaining power increasing, you actually can ask for a higher wage. The parameter alpha captures the strength of the effect of unemployment on wages. So we can write then the relationship between price and the relationship between price and expected prices, markup, and unemployment and catch-all variables as equation 3. Equation 3 gives us the relationship between price level, expected price, and unemployment rate. What follows is a derivation of the relationship between inflation and expected inflation. Now, from here, we know we can take the equation we saw above in equation 3, and all we do is we divide both sides by a lagged price, i.e. last year price. And then from there, we try to understand how do we determine, how do we convert this into changes into inflation, i.e. here we're gonna get current inflation, here we're gonna get expected inflation. Simply, and what we do there is use a simple trick of adding, subtracting price, last year price plus last year price over last year price onto the first part, and do the same on the second part. Now, when you do for the first part, you get that the ratio of price over previous price is merely 1 plus inflation if you simplify. Well, similarly, the ratio of expected price over last year price is 1 plus expected inflation. You substitute both back into equation 8.1, and then you get the relationship of which is 1 plus mu, 1 plus pi is equal to that, as you can see this. Now, if you assume that pi and pi e and mu are not too large, we can approximate the left-hand side of the equation to become this. Replacing the above equation, we can obtain that current inflation is equal to expected inflation plus mu plus z minus alpha ut. We can drop the time index and to obtain what is in the book, and this is the equation you get, which is in equation 8.2. So what does that mean? Equation 8.2 implies that if you increase expected inflation, it leads to an increase in inflation, actual inflation, i.e. if you change the independent variable, the dependent variable should respond to it. And that's our shifters, if you remember. This is because if you increase expected inflation, it leads to an increase, it leads to a 1-to-1 increase in prices. If wages expect higher prices, they set higher wages, which lead to in turn to an increase in prices. Similarly, if you hold expected inflation constant and you increase your markup or increase your catch-all variable, your inflation will increase according to the equation 4 above. Right. Similarly, for equation 3, if you hold expected inflation constant and you decrease unemployment, it leads to an increase in inflation. So there's a negative relationship there. So merely it's just an interpretation of it. Okay, so what happened earlier, we saw that the assumption Phillips and Solo were making was that inflation actually does vary around a fixed term, i.e. last year inflation is, expected inflation is just some constant value, right? I.e. inflation is not persistent, so remember that. So if then inflation is not persistent, i.e. pi is equal to pi bar, then this should have become this. Under this assumption, we can observe the negative relationship between unemployment and inflation that Phillips found for UK and Solo and Solo found for US. So apparent trade-off and its disappearance. So Phillips and Solo and some also find this again that there is a trade-off between inflation and unemployment, i.e. if policymakers are willing to accept more inflation, they could achieve lower unemployment. The relationship between unemployment and inflation showed by equation 4 fit US data well for a period of 8 years during the expansion period. After expansion, things change. Starting in 1970s going forward, the trade-off between inflation and employment disappeared. And why did it disappear? Actually, it's because wage setters changed the way they form their expectation about inflation. It seems in 1970s, higher inflation became more persistent. High inflation this year likely to be followed by high inflation next year. Wage setters started to take into account the inflation persistence when forming expectation. In turn, the change in the wage setters form expectation changed the way the relation between unemployment rate observed previously. So expectation formation. Suppose that inflation expectations formed according to the following. So we saying that if you assume that actually this expected inflation is given by some form of a derivation of whatever inflation is held constant and last year inflation. So expected inflation this year depend partially on constant values. This one, and which is weighted by this, and then last year inflation, which is weighted by theta. The higher the value of theta, the more last year inflation lead to workers and firms to revise their wage, to revise their expectation of what inflation will be this year, and so higher the expected inflation rate. We can consider what happened in 1970s as theta increasing over time. So long as pi was not persistent, it was reasonable for workers and firms to just ignore past inflation and assume a constant value of inflation for the period. For the period Sol and Samuelson did their study, theta was close to 0 and inflation was roughly given by current inflation, expected inflation being equal to the constant inflation, and the Philip curve is given by this relation. As inflation becomes persistent, workers and firms start changing the way they form expectation, i.e. the parameters increased. The parameter theta increased. So what's the implication of theta varying over time? Okay, so we substitute the equation 8.5 into equation 8.2 in the book, and then we obtain this relationship. So when theta is equal to 0, we get the origin of Philip curves. That's purely simple. Then when theta is positive though, the inflation depends not only on unemployment rate, but also on the last year inflation rate. When theta is equal to 1, the relationship becomes this as in equation 6. So when theta is equal to 1, the unemployment rate affects not the inflation rate, but the change in the inflation rate. This is important and you need to pay attention that that's actually one of the crucial changes you will observe. Higher unemployment rate lead to a decrease in inflation and lower unemployment rate lead to an increase in inflation. Thus, as theta increases from 0 to 1, the relationship between unemployment rate and inflation rate disappear. So if you take these two equations, the Philip curve equation and the adaptive expectation, you can see that it actually gives you a very interesting macroeconomic policy implication. So let us see what are the policy implications of this. So recall that if we set theta equal to 0 in the adaptive equation, we get the origin of Philip curve. The coefficient theta then measure the extent of trade-off between inflation and employment and have very important policy interpretation. A macroeconomic policy that reduces unemployment by 1% increases inflation by theta, and the converse is true. Philip curves and the natural rate of unemployment. So the origin of Philip curves imply that there was no such thing as a natural rate of unemployment, i.e. if policymakers were willing to tolerate high unemployment rate, they could maintain a lower unemployment rate forever. Original PC held perfectly in the 1960s. Yes, Milton Friedman and Edmund Fels questioned the existence of such trade-off between unemployment and inflation. They argue that such trade-off could only exist if wage setters systematically under-predicted inflation, but they are unlikely to make the same mistakes forever. Further, Friedman and Fell argue that if government attempted to sustain the low unemployment by accepting high inflation, the trade-off will ultimately disappear, i.e. unemployment rate could not be sustained below a certain level, i.e. natural rate of unemployment. So again, we take the previous equation and we manipulate them around to obtain the natural rate of unemployment. And we get the natural non-accelerating inflation inflation rate of unemployment. So this is what we call an arrow, right, from equation 9. Now we can rewrite the equation as such, and then we get equation 8.9 or equation 10. If expected inflation is well approximated by last year inflation, then the equation finally becomes this, which is a change in inflation is given by a deviation in unemployment from the natural rate. So, and the implication of such is if current unemployment is less than natural unemployment, it implies that current inflation is greater than future unemployment or last year unemployment. Surely, similarly, if your current unemployment is greater than your unemployment, then your current inflation is less than last inflation. So the natural rate of unemployment is the rate of unemployment required to keep the inflation rate constant. So natural rate of unemployment to keep the inflation rate constant, i.e. the thing is equal to 0, which means UT is equal to UN. That is what natural rate of unemployment is all about. So the relationship between unemployment and inflation today is well captured by the relationship between the change in the inflation rate, the change in inflation rate, and the deviation of unemployment rate from the natural rate of unemployment. So that is important. So today, what we're talking about is what this equation depict, equation 11 depict, and not what the original Phillips was showing. So variation, so what caused then variation? Natural rate of unemployment across countries. Remember, wage setting and price setting is a function of markup, cultural variables, and alpha, and they do not, and are not similar across countries. So we do not expect natural rate of unemployment to be the same across countries either. The markup and the institutions, i.e. institutional structure and the labor union across countries as well varies, and they are not constant over time. So even there is variation of natural unemployment over time because of changes in the markup and the institutional structure across countries. So higher inflation and Philip curves. So recall that in 1960s and in 1970s, and inflation became persistent. The wage setters changes the way they form inflation expectation. The main lesson from that are as follows. The relationship between unemployment and inflation is likely to change with levels and persistence inflation. Not only does the workers then form the expectation change, but also the institution arrangement are likely to change. When inflation rate become higher, inflation tends to also become more variable, and workers and firms become reluctant to enter into labor contract that set nominal wages for a longer period over time. If current inflation is greater than expected inflation, real wages may plunge and workers will suffer a larger cut in their standard of living. Similarly, if inflation is less than expected inflation, the real wage will rise sharply and firms will not be able to pay their workers and they're likely to go bankrupt. So to correct for that, firms actually don't like long-term contracts, so they set short-term contract and they actually index them. So index is like using the price stabilizer thing, where you actually you are trying to weigh them in such a way that the wages and inflation actually adjust automatically. So if you do that, you might let us look at it by having two form of a labor contract, one which is indexed and one which is not indexed. From it, and if you substitute in the equation, you see that you obtain equation 12. When lambda is equal to 0, all wages are set on the basis of current expected inflation being equal to previous inflation, and the equation reduced to that, which is what we know already. When contractor index are positively indexed, the portion of wages set on the basis of actual inflation rather than expected inflation. So we substitute it, and we get the relationship where the deviation of inflation is given by another factor now, not just the mere alpha. This implies that wage indexation increases the effect of unemployment on inflation. So the higher the lambda, the larger is the effect the unemployment has on the change in inflation. In summary, without wage indexation, lower unemployment increases wages, which in turn increases prices. But because wages do not respond right away, there is no further increase in price within a year. While with wage indexation, an increase in price leads to a further increase in wages within a year, which lead to a further increase in price within a year, and so on and so on. The effect on employment on inflation within a year is high. So this is the end of my lecture today, but I need you to know that this is not, the notes are not free of typos and stuff, so be nice, read them, and send me an email if you find horrid mistakes and tell me to correct them. I will do that. And I hope that you will have a wonderful time of study. So thank you very much, and I hope to see you soon. I will provide some summary and some question in my next chat. Thank you very much.